How to find internal rate of return using Excel. This is the equation for net present value, and internal rate of return is just the discount rate which turns the net present value equal to 0. And that's all you need to know about the theory. So let's look at a very simple example here in Excel. We have a discount rate of 10%. And at this point, it doesn't really matter which one we select, just pick arbitrarily, just pick whatever. Then we have a little table here with the year or the time period to be more general. That goes from 0, 1 to 3, all the way to, in this case, 10. Then we have the cash flow, which is again just like an input here, an example. We have an investment cost of 10,000 monetary units in time period 0, so that's right here and now. And then annually we have a positive cash flow of 5,000 from year 1 all the way to year 9. However, in the 10th and final time period of this example, we have a negative cash flow of minus 45,000, which we could, I guess we could interpret this as some kind of decommissioning cost. Then we have the discounted cash flow. Let me just solve the equation here. It is the cell to the left there, so the cash flow, divided by 1 plus R, the 10% interest rate up here. And notice that it's a relative reference to the cash flow, but a fixed reference to the discount rate to the power of the time period. So for the first discounted cash flow, and I see there's a spelling mistake here. Let's see. Discounted cash flow. That seems about right. So the first discounted cash flow is just going to be the same as the undiscounted cash flow because it's the time period 0. But the idea is to autocomplete there. So once we have the equation down here, we could autocomplete to the rest. And here you can see the equation. It's just the same equation, copy and pasted. And then to find the net present value, we have some different alternatives here. We could just use the net present value equation and modify it a little bit because, as I talked about in another video, the net present value equation of Excel doesn't actually calculate net present value. But since you already have manually calculated the discounted cash flow, we can just take the sum. The sum of the discounted cash flows is going to be equal to net present value. So the question that I want to tackle in this video is how exactly do you calculate the internal rate of return? So as I previously stated, the internal rate of return is just the discount rate up here, which will give us a net present value of 0. So how would we be able to find that? And there are several different ways you can do that. One is kind of manually, since you have the calculation here for the NPV. We can just guess here. So let's see, let's try 3%. Okay, that didn't work. 4%, 5%. 7%, okay, that seems kind of close. How about 7.5? Okay, that was a bit too much. And let's get some more decimals here. How about 7.3? Okay, that was we overshoot it again. So how about 0.4? Oh, that's really close. How about 7.45? Oh no, that's too much. So we can just keep trying here and guessing at different discount rates until this becomes maybe not perfectly equal to 0, but sufficiently close. So that would be a very tedious way of doing it. Alternatively, we could use goal seek. So if you go to data here, and then go over to the what if analysis, we have goal seek. So set cell, let's see, that would be this one, the NPV, set NPV to the value of 0 by changing the discount rate. And we can click OK. As you can see, it is now 0. That would be our discount rate of 7.41 approximately. I guess there are some more decimals in there. Yeah, there's quite a lot of decimals here. So that would be another way. Alternative to that again, if you don't want to do it, or before I go to that, you don't have to use goal seek. You can also use the scenario manager, where you can basically do exactly the same thing. So the scenario manager is a little bit more complicated because you can add different restrictions and that kind of things. But you could kind of emulate the more simpler goal seek by using the scenario manager. But this is basically the same thing. It's a trial and error, more implement a more automatic and systematic way rather than doing it yourself. But alternatively, we do have the internal rate of return function in Excel. So IRR, internal rate of return, acronym for internal rate of return. If we select the cash flows here, and then there's an optional parameter which we're going to ignore for now. If we do that, well, again, we get 7% or approximately 7.41%. So that was an odd way of doing it. However, there is an issue with the 3 approaches, or potentially 4 approaches I showed you so far. That is that it is only showing one particular internal rate of return. As it turns out, for this particular example, there are actually 2 different discount rates, which would give a net present value of 0. And I think the best way to actually to solve these internal rate of return questions is to create a data table. So down here, we don't have much quite yet, but have a data table, 2 columns, discount rate and the net present value. So let's start with net present value. It's going to be equal to the net present value, which we calculated up here. Let's see, I can put this back to 10%. So this is just going to be equal to a cell which is calculating your net present value. And it's important here that it's not hard-coded. It needs to be that the discount rate is factoring into this net present value. Next, I'm going to make a whole column here of different guesses or different values of the discount rate. So I'm going to start at 0%, and then I'm going to add 0.1 or 0.01, there you go. If I click Alt F3, I get to activate the name box over here. So let's see, C1024, put in a placeholder text and autocomplete. That gave us 100%. So I just generate the different values of discount right there from 0 all the way to 100%. You don't need to use the whole range, but I prefer to do it that way. You don't necessarily have to use this level of granularity. You could go like 1%, 2%, 3%, 4%, or 0.5%, whole percent, 1.5%, doesn't matter. Next, we are going to select this table. So if you are in this column here, you can hold Control, Shift, arrow key to the right, and then arrow key down to select this whole table that we made. Then we go to Data, and we go to, let's see, where did we go? Brain freeze. We go to What If Analysis again, and we choose the Data table. We get this little pop-up window, and on column input cell, because the different guesses of discount rate is like contained in one single column here. So in the column input cell, we are going to select the discount rate, and we're going to click OK. And whoa, something happened here. So let me just explain what happened here. So what's happening here is that it's recalculating net present value again and again, but for every row, it is substituting a new value of the discount rate into the cell up here. So what I'm going to do now, I'm going to select this net present values, exclude the first one because that's just based on the hard-coded 10% up here. I'm going to insert a lines chart, and it doesn't look very nice. We're not going to deal too much with the aesthetics of it, but we need to change the x-axis at least, because now by default it just goes 1, 2, 3, 4, 5. So select data, on the right panel here, edit, and we can select these different discount rates. There we go. And I probably don't need that many decimals in here. Let's see, 1 is sufficient. And here we go. It's not so easy to see, but this is the relationship between net present value and discount rate. So relationship between NPV and discount rate, and on the x-axis we have the discount rate. Let me just add that. So here we have the discount rate. And on the y-axis, we have net present value. So the interesting to note here is that the curve is crossing 0 twice. There actually is two different internal rates of return. One, as we can see here, is kind of hard to spot, but somewhere around 7%. And another one over here at, yeah, it's kind of hard to see, between 40 and 50, yeah, around 45, I think, 47. So actually there are two different internal rates of return. And the methods we showed so far didn't identify that. It only identified the very first internal rate of return. So how can we find precisely? So this gives, like, by eyeballing here, we can see like approximately that there are two different, we see that there are two different internal rate of return, and we can approximately see where that is. Now we could just scroll down here until we see, when is it going from negative to positive. So here, for instance, it's negative for 7.4%, but positive for 7.5%. So somewhere in between, there would be like the first discount rate. But with this level of granularity, we can't really see precisely. It's just somewhere between these two numbers. If I scroll a little bit more, it's positive here, and at some point it will become, well, negative again. And I think we scroll past it, yeah, here. So 42.3 and then 42.4. So that will be around the second one. So to find precisely, we can actually reuse the internal rate of return function up here by adding a different guess. So I'm going to write here, here's a guess. Okay, actually let's do it like this. I'm going to have a guess of 0%, and then the internal rate of return for the cash flows here, 7% as we got before. But if I add a guess that is, let's see, yeah, probably beyond this peak here. So if I, let's see, let's try, if I try 30%, initial guess of 30%, let's see, that did not work. Okay, how about 50%? Let's see. Oh, yeah, I forgot to actually add the guess. My mistake. This doesn't do anything right now. Okay, so if I guess, let's see, where would the peak here be? Somewhere past 19%. So let's try 20%. If I guess 20%, it will identify the second internal rate of return. And if it's less than 20%, or hard to tell here, but okay, let's say less than 15, it gets to 7.41. So I think we can just guess here and see until when it changes. 18, 19, okay. So somewhere between 18 and 19, that's probably the peak here. It will change what the outcome will be. So the issue here is that the internal rate of return will only provide you with a single one of the internal rate of returns, if there are several. And it will give you the one that is closest to the initial guess. We don't know exactly what is considered an initial guess in this function, but I'm guessing it's probably 0%. So if you're going to find the internal rate of return, I think the best approach is to create this data table, generate different values of the discount rates, so you can create this curve. And then based on the curve, you can tell, okay, is there one internal rate of return, or are there several ones? If there are several ones, you can approximately see where it is, and then use internal rate of return with a guess close to the, the one you eyeballed, and you will get the two precise different internal rates of return. So that is how you find internal rate of return using Excel. Fascinating stuff. So I don't know, please comment, like, and subscribe, and hit that bell thing for early notification. Yeah, I think that's how it goes. Yeah, okay. I'm gonna turn this off now.